about tests. So when someone tells me a hint about a test, I like to pass that along to you directly. So on Thursday, I attempted to leave you video notes, but as usual, it failed because I don't know. That's another story we can discuss of why can't I upload things without it taking 3 hours. I don't know. Why is it so fast on school internet, but 3 hours at home? Ridiculous. It is ridiculous. So this formula, I think, while it's great and everything, you don't need to memorize it. So you had to learn about it on Thursday. It's dealing with margin of error. You don't have to memorize it. The main point of that story, the main point of this, it's on the bottom of page 4. The main point of this was, hey, could we reduce our error if we increased our sample size? Like, is there a certain sample size we need for whatever experiment we're running or whatever in order to have a certain margin of error? Because when you and I say we're 95% confident, this is stats. So even when we say we're 95% confident, we're really not that confident that it's in that region. Like it's 0.23 to 0.75. Like we don't really know it's in that region. We're 95% confident, but you know, could we increase our confidence a little more and maybe not have so much error like that? We might not need to be 95% confident. Maybe we should only be 92. Heck, maybe we're so right it's 98. So there's always wiggle room in stats, as always. There always is. And the solution, which has been the solution for Chapter 7, and is still the solution for Chapter 8, is increase your sample size. If you increase your sample size, you decrease your variability. If you decrease your variability, that means you're going to have a smaller z-score, which is going to lead to latch to score so much better. So increasing the sample size is the key. So if you have a question like this that asks for the margin of error on the actual exam, I would focus on increasing the sample size. You don't actually need to know a formula. You just need to know maybe I need to increase the sample size, and I bet you can figure it out through process of elimination. Meanwhile, if you've forgotten our formula for difference of proportions, or good lord, our formula for proportions, we have a problem. So it's supposed to be p hat and then what? There's a plus or minus. Z star. Square root.
Of that thing, basically. Times that thing.
P hat, 1 minus p hat. All divided by. And you have to know it because why? No. They describe it, but if you don't actually know what the description means, then that's pointless. So, you know, I eat my words all the time because that's what happens to teachers. They say things and they find out other things. I told Hunter last week, for the love, I know I need to tell you, I'm sorry. I told Hunter last week, for the love, if he is going to stick only to his calculator, and I'm going to go back up to the top. We were working this problem when I told him that. I said, Hunter, for the love, if you put one prop z interval and the things you plug in and give me the interval, and that's all you have, you're either getting an E or you're getting an I, so I need you to show more. That's what I said. Yes, dear. Yeah. Well, it's okay if he calls it the test as long as he tells the X, N, and C that he's giving. It's okay if he explains it. And I would like to see this line. And on this next test, especially if it's a figure response question, if he doesn't have this line, even if he is completely correct, I'm only going to give him the P because I'm that person. So he's better have a line full of work. But in the future,
So if I do this?
that's fine. But what I'm going to suggest for Hunter and on my calculator, I like formulas. I don't have a problem memorizing a formula. But for all my calculator button pressers who are not into memorizing formulas, it might not be wise to actually list this exact formula on the test. It might be wise to go straight to plugging in the math. Are there any thoughts as to why it might be wise to go straight to using numbers rather than using P's, Z stars, and N's and anything like that?
I mean, I don't know any reason like that
So some people are making a mistake when they write down this formula. What mistake are they making, and why is it costing them so much? It's got to do something with P, yeah.
P and P hat.
P and P hat. Some people are doing P and not P hat. And then you get majorly counted off because P is for what should be row, but it's for the population, whereas P hat is just for the sample. So suddenly you've messed up everything because literally you used the wrong letter.
So
And they will count off for that.
even if the math is right.
Even if the math is right, if you put P and not P hat and you wrote down the formula, you're going to get a P or an I.
Will this formula forever just be P hat and not P?
If we're dealing with a sample, it's always going to be P hat. If we're dealing with a population, why are we doing this math anyway? This whole thing is for us to get a confidence level that we're like this, 95% confident the true mean of the population. Like if we knew the true mean of the population, why would we need a confidence level?
Wait, so you're saying don't write the formula because you did put the formula and your math is correct. They're going to still count because you wrote the wrong formula?
They're going to count off if you've literally forgot to put the little hats. They're going to count off. Yes, because again, if I take off the hat, it's just a P, and that's implying population.
But you still have to say the math.
I know, but no, that's what I learned. They will count off for that. It was a big, hot debate a few years ago, actually. Yeah, about people who had, they had the math, they did all the things you and I did, but literally because they didn't put the hats on the formula they wrote down, they got counted off. Well, the logic is that when you're looking at your formula sheets, while we don't have this exact formula, when you're looking at your formula sheet, you know that we do have the description of it. And you and I have talked about a standard deviation of the statistic, so statistic meaning sample. And so what we would be writing, I don't know, I'm going to overly complicate it if I say all those words. Again, this is stupid, and you don't even have to memorize this today. It's just I learned it on Friday, and I don't want to forget to not tell you. So seriously, it's probably best when we do all these problems. They're great practice. Probably best to not even put the whole formula, though. Go straight to numbers, because if we forget to put the hats, suddenly life's over. Now, am I going to continue to write it? Yeah, because I'm going to remember the freaking hats. But if you think, I'm a hat forgetter, then don't put it. Do not put it.
A hat forgetter.
Yeah. Okay. Okay, let's move along to the next page. So, I like Kenzie's suggestion. So let's get a plan for the week. Today is supposed to finish up with my chapter 8 bingo.
Is this the last part of the chapter?
Yeah. So we are in chapter 8. We've done 8.2, and we are now dealing with 8.3. And what I think is we'll do 8.3 today and tomorrow. I think we'll do something kind of like a worksheet practice thing Wednesday, review Thursday, test Friday for chapter 8. That is my plan. No, I stink. I'm working on it. Okay, so chapter 7 built to chapter 8, which is going to build to chapter 9. So every chapter right now is building on each other. So if you're having trouble with reading the table or understanding the calculator buttons, please come see me another time so I'll gladly work one-on-one with you. That would be awesome. Terrific. That would be terrific. Okay, so we've been doing so far proportions, hence the P's in the hats, because we were doing proportions. As we discussed last chapter, we're either doing proportions problems or we're doing means problems. So now we've done the proportion side of confidence intervals. Now we've got to deal with the mean side of confidence intervals. So if you look on page 6 at the top, again, if we actually knew the true mean of the population, then we wouldn't need any of this math. This is all of us estimating stuff from a sample because we don't know the truth about a population. If we knew the truth about a population, all this math would be stupid, because if someone said, what's the mean, you would just tell them. You would not have to do any of this. Okay, so if we're wanting to estimate a population mean, it depends on if we know the standard deviation. Normally it's unknown. When it is unknown, we use something called t-distributions. Okay, so if you have your formula sheets, you know, you and I have been dealing with the z's. That's all we did chapter 2. And heck, the z's are all we've been doing lately with z stars. Z stars just meant look at the z table, right? So we've been zing it, and finally you get to go to a new table. I know you're super excited about this.
Yeah.
We get to go to the table that says t. So if you are dealing with a means problem, you get to use the t table. So seriously, I would probably make a note to myself that says, I would say C star for proportions, and then T for means. I don't know, or the word for one and not for the other. So we're using T's or Z's. T's are for means, Z's are for proportions. Well, Z stars. And you're like, Miss Compton, how on God's green earth am I going to know when to use which formula? Because that's what we discussed last chapter of how did you know on a problem when it was a proportions or when it was a means problem. When it's a means problem, they normally tell you a mean and a standard deviation. When it's a proportion, they normally give you a percentage, or like 50 out of 250, and then you make your own percentage. And another way we can know in this chapter that it is truly a means problem is because there's an extra step with means problems. That's what this whole DF column's for. So we see this weirdo column that says DF. We're about to get to use it. And then, more fun than that, at the bottom, we can find our confidence level. So if we want to be 95% confident, we would be looking in this column. Or 95 is that column, sorry. Can't point today. Woo! So, and the DF column is what's going to make things different, and the DF stands for degrees of freedom. So let's read. It says, draw a simple random sample of size n from a population that has a normal distribution with mean mu and standard deviation sigma. The test statistic t has the t distribution with degrees of freedom, and then they have a formula for it, and it's n minus 1. So first thing we need to know, degrees of freedom, n minus 1. So that's how Kenzie's going to know it's a means problem, is because they're probably going to tell, say, you know, again, she's told a standard deviation, she's told a mean or something, and she's going to need to know the degrees of freedom. But if she knows the sample size, it's just one less. So if the sample size is 50, the degrees of freedom is 49. Okay. The statistic will have approximately a t n minus 1 distribution as long as the sampling distribution of x bar is approximately normal. And then in general, t-distribution t-curves have more area in the tails than the standard normal curve. So you and I have been drawing the same picture for forever. Got my standard normal curve. A t-table, Lord, come out today. A t-curve is slightly different than our normal z-curve. They still appear bell-shaped, but they are not quite normal. There's a different t-curve for every possible value of sample size n. So literally, we are going to be using technically a different curve. So technically, that's why we're using a different table. But as we keep learning, as n gets larger, standard deviation goes down, and the more and more we get closer to an actual z-table. That's what that last sentence says. However, as n gets larger and larger, the t-curve looks more and more like a normal z-curve. Okay, and none of that is really something that has to stick in Sally's brain, except for the fact that when she does means, she uses means go with t. She uses the t-table, because technically that t-curve is different than that z-curve. No, because we've been doing proportions this whole time. Oh, you're meaning in reference to last chapter. No, we did not. The T part did not come into play until we started talking specifically about confidence intervals. So if you're on a problem and it doesn't say something about being confident or 95% confident or something about a confidence level, then you can, the way you've been doing math is perfect. Okay, this formula is terrific, and God bless it. It's not in the packet either. So, second formula we gotta learn. Yes, dear. Can you go to the bathroom? Yes, you can.
I'm on a schedule. I can't explain it. We don't.
Well, I guess it's not
It's really not that bad. Okay, so you're like Miss Confident. Well, on God's green earth, I'm gonna learn another formula. You already expected it to be, in life, they give you like our normal mean is this. We're given that. They give you your sample mean. SX is standard deviation. You've been doing that because you've been doing x bar minus x dividing by that standard, or I don't know how we even writing it. You've been doing this for z-scores for forever. You've been using this exact thing, this. You took, the normal mean was 15.9, but our bottle was 16.1, so 16.1 minus 15.9, and then dividing by the given standard deviation. You've been doing that forever. SX, that's a great question. It's going to be the sample standard deviation.
So it's basically just, it's kind of like a z-score because it's sample standard deviation divided by the root of the
Yes, it's exactly like that. Yes, it's exactly like that. So, again, the whole problem is that, sad day, we've been living in a world where every single time they've been telling us the standard deviation of the population. So normally we've been doing like our sample minus the average dividing by the standard deviation of the population. We knew the stuff about the population. Is that realistic? No. We never actually know the stuff about the population in real life. When the population is the world, how are we going to know the truth? We don't know the standard deviation. We don't know any of this. So because, in reality, we don't know the standard deviation of the population, we do know the standard deviation of the sample, and if we divide the sample by the square root of n, which is just reducing some variability, because n is our sample size, so we're trying to reduce variability, by dividing by the square root of our sample size, square root sample size, and you don't have to write all that unless you're just trying to explain it to yourself. It's really not that big of a deal. Again, you've been doing this forever with z-scores. I've seen every single person successfully use this. All we're changing is the fact that we're dividing by the sample standard deviation divided by the square root of n, because we don't know the true standard deviation of the population. Whew. That is my name.
Which one's in the library?
Yes.
Just disappearing from the table whenever
I know, right?
sad.
Isn't it though? Okay. Whew. Felt like that was a lot to come out. Okay. Let's talk about our first problem so we can actually apply all this junk Miss Compton is trying to throw at us at once. Again, how do I know this is going to be one of those problems where I need to use this T crap? Because it says 95% confidence level. It says mean. No, we're still going to have to check the same old junk we've been checking. We're not going to check it this problem because we're in a hurry. But should we check random? Yeah. It actually already says normal, thankfully. We should probably check independent as well, but we're not going to this time because we're in a hurry. So Suppose you want to construct a 95% confidence interval for the mean mu of a normal population based on a simple random size of size 12. What critical t star value should you use? Okay. What should we use? There is a calculator written for this. There's always a calculator written. There's always. First things first, we're wanting to use our cool new t table, but we've got to be able to consult those degrees of freedom. The degrees of freedom are always one less than our sample size. Our sample size was 12. So our degrees of freedom is 12 minus 1, which is 11. I know I wrote that out and that was dumb. I get that. Screw the point. And we were told specifically we want a 95% confidence level. They told me that in the problem. So using my cute little table, I see degrees of freedom 11. I need 95%. Degrees of freedom 11. Where do they align? 2.201. So that t star value that I'm going to use, that you and I are not even calculating, we know that the t star we're going to use is going to be 2.201. Again, you and I didn't even have to use the formula. We figured it out using the table. It's a t star. Okay, so again, we've got, and I know my curve for the t star looks just like my curve for the normal curve. My bad. So we figured out a value, and that's great. Perfect question. So again, we figured out the degrees of freedom was 11 because it's 12 minus 1. You take your sample size minus 1. And if you look at the bottom, it's where it has its confidence levels. We were told 95% confident. So literally where they aligned. Okay, I don't know where I was going in my picture. I lost my train of thought on that one. Whew. I'm telling you, even I gotta not have this class over here. This one, my brain goes, whoa. Okay, so Hunter, as always, and as you should be, wants a button. We've been doing, so we're told the number. We need to calculate the probability of that. So normally he would use inverse Z. Today, because we're doing t values, he's going to use inverse D. So let's go on our calculator. If you press second and then vars, you know when you are wanting the inverse Z-score, you did inverse norm. But now, since we're not doing the inverse of the norm, we're wanting inverse T. So we're wanting number 4. And we're still doing the same thing. Yes, God bless you. The area is still what we've been doing in life. So you know how we were saying it was 95% here, so it was 2.5 on each. So that's why we're going to do area of 0.025. And we're still going to do the degrees of freedom being 11. Yes, dear.
So when you have a normal distribution, you use the normal, and then you don't know the mean of the distribution. Am I getting right?
If they start telling you,
It's like if you don't know the mean, you use the inverse T.
if they tell you a confidence interval and they don't know the mean of the population, yes, you use inverse D. Yes. Okay, so 0.025. Degrees of freedom, 11. Yeah, again, it's still like we were just doing with the Z-stars, how it was really plus or minus because we're dealing with both ends. So it's still it's going to be plus or minus 2.20. You know there's about to be another formula with a T-star, the way there was just a formula with the Z-star. We're just building to it. It's a pain in the rear.
So what is the T?
The T is just talking about the T distribution and how it's different than a Z distribution. But, I mean, you already called on the key thing of a Z distribution. We knew the standard deviation of the population. Whereas with a Z distribution, we only know the standard deviation of the sample.
Right.
Literally the difference. And technically the T curve is different than the Z curve. But, again, as Shalia was asking, if they tell you a confidence interval and they tell you means, we're using T. Means go with T, proportions go with Z. Okay, so we still got the 2.201 technically. And all this is leading to, well, I doubt highly that you actually memorize that bad boy. It's leading to a very similar formula. So, we were doing P hat plus or minus the Z star, and then it was square root of P hat, 1 minus P hat, all divided by N. There's still a formula for confidence interval for means, but of course it's different. It doesn't have P hats because it's not for proportions, it's for means. So the standard error of the sample mean X bar is, I can't read. The standard error of the sample mean X bar is Sx divided by square root of N, where Sx is the sample standard deviation. It describes how far X bar will be from U on average in repeated simple random samples of size N. Again, what really sucks is you have this formula in your formula packet, but they don't give you the P hat one and they don't give you this X bar one. Literally the same words. Same words. Completely. And you're like, yeah, I would have done hats for proportions. I would have done bars for means. But besides that, like, why we got to change all the other letters? Jesus, take the wheel. But it's okay. Because once we do them a couple times, you're like, okay, I can keep this straight. It's like when you used to learn about sine and cosine. At first, I was like, are these the same thing? And then, by now, I'm like, oh my gosh, they're so different.
Yeah,
By now. Yeah. It took a while. Okay, bless your hearts.
Question.
I have an answer.
What's the next? Does this apply to, are we going to have to know this for the next chapter?
Sadly, yes. So 7 builds on 8 builds on 9. But seriously, like I was talking to Kenzie this morning, if you freaking have finally, which you haven't, Kenzie's the only one who's super into checking the conditions, so I need you all to get on board with her about check my conditions every single day. Yeah, I appreciate her being a rule follower. Seriously, for the next, from February now till May, or at least the next 2 chapters, you check the conditions. You check the conditions. You check the conditions. And guess what? They end up being, most of the time, the same freaking conditions. The same freaking conditions. Yet, for some reason, we're never checking them. I don't know. I swear every time I work a problem with you, we check them. I don't understand. Okay, what makes... So we've got to do random, blah, 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 blah. You already know how to do that one. You want to read the words, you can.
Data come from a random sample of size N from the population.
Speaking of random, independent, and normal, another reason I'm mad at you about your thing on Friday is it should have failed the conditions. Because I don't know about you, but I did not meet the... Mine failed because my P times N times P and my N times 1 minus P was not bigger than or equal to 10. And why do I know this? Because we did the exact lab I left for you with the thing I went to on Friday. I'm talking about, I'll show you.
Yeah, but it says
if it didn't meet the conditions, proceed.
Continues it if it is.
I know. See, I did it. But mine didn't. Mine failed the conditions.
Dude, wait, so you do have candies?
No, this was at my thing. Do you want more candies? You just need them in your life.
Yeah.
You have to have them.
Jackson.
The stuff was acting like Jackson's mama, and she was like, "You can't eat all of it."
I mean, to be fair, he was eating large amounts off like dirty paper.
The paper was just handed to me. Describe how it was dirty.
It was on the desk and so your pencil head, dude.
Did she limit how many I could have? Why do I have 2 giant bags full left?
You do?
Dude, what?
Can I have them?
I want some.
I will give you some, but you can't have 2 giant bags.
I took all 30 of the ones from each table home.
See, that's the problem. There we go.
God bless you. God bless you.
She's awesome. What do you mean?
Okay, God bless you.
She knew.
I think it was her hard work.
She made fun of me because I had a DS, so she. Gave
I think
perspective
she.
on
I
it.
don't. I have lots of opinions. I'm gonna keep. I'm gonna.
Well, I make fun of you, yes.
I mean.
Yeah, but
Anyways, okay. So Shalia should be used to checking the sinking conditions by now. It's still random, independent, and normal. I like the way my teacher, yeah, seriously, the lady who handles all my training does the independent. She writes it a little better than we have been. She does 10 times n is bigger than or equal to n. Now, you don't have to start writing it like that if you don't want to. But that way she thinks it through. Like, if I do 10 times my sample size, is that really bigger than or equal to, less than or equal to, sorry, read it the wrong way. Don't you hate me do that? Is that really less than or equal to my entire population? So I really like that she writes, if you want to adopt it, you can. If you just want to check it, you can. Why is normality easier with means than it is with proportions?
What?
Why is normality easier with means? You have options. What is the extra option you have? Yes. So all we have to do is have a sample size of 30, and that doesn't work for means. Proportions. It only works for means. Okay, so we're still doing the same thing.
So what do you do for proportions for normal?
It either has to be told that we're normal, or we've been doing that NP greater than or equal to 10 n times, and we've been having to use p hat lately.
So the one you did on the worksheet was a proportion.
It was proportions.
So what is that?
Yes, it was. I had mine failed this step.
What are you said 3 conditions?
The random, independent, normal. I wrote so for.
We have to pretty much, like, if they don't tell us, we have to just see if they picked it out of the
Okay, so we could talk about that. So let's talk about the activity you did on Friday with the yeah. What are those things called?
The candy hearts, whatever.
Yes. Okay, the conversation hearts. Okay. So I wrote that it was random because you were randomly given a sample from the teacher, plus the bags themselves were randomly shipped to a store, plus they were randomly given from the distributor to the store, and you could go on and on rambling on about how it was random that you got the conversation hearts you did. Okay, so independent, I did this, but my proportions of pinks did not end up being greater than or equal to 10, so I failed this. I didn't have many pinks. Yeah.
But there's a reason for that.
We had
Yeah.
47.
Okay, so first off, we counted all of the pinks and dumped them in the bag out.
And then realized it's only supposed to be 50. So all the pinks are in the bottom of the bag when you put it back in. But we only got one.
We shook it up really good, but it just
We didn't.
Well, but that's part of it. You could say it was random because you shook the bag before you pulled out your sample, too. That's another argument for random.
I don't know.
Ours was kind of biased though, because we actually did pick one pink out, because originally we had 0 out.
I understand picking out the one. I think I only had one pink. So, no, we had people who had no pinks at our thing. So it's not a uncommon thing. Yes, dear.
See, we met the conditions. Like, so we do the same thing.
Okay, yeah, even when I failed the conditions, I just wrote a sentence like, conditions failed, but continuing on, here's the math. So even when the conditions fail, we keep going in stats class because, we still want to do that. We're in stats class.
What did we do right on this? I don't know.
Nothing.
You did everything right except for the very last problem because most people just have straight up math, whereas Kinsey actually did random, independent, normal, but she ran out of time to do the straight up math. Like Hunter has the straight up math and the sentence summarizing like I'm 90% confident, blah blah blah,
Come on, Hunter.
but he didn't actually check the conditions.
So the random used NP greater than
No, the random it says the word random, or like I'm saying, you describe how it's random.
Okay, so
The normal you use that, and then independent you got to show your sample is not, and then you can just write something dumb like we only had 10 times 50, so that's 500. Surely there are more than 500 conversation hearts out there in the world.
I don't understand when you did that.
Did you write those words?
I didn't write the word.
Okay.
No, we assumed that the population of all the pinks in the whole NECO company is greater than 10 times the number we got.
You wrote that out.
No, but
Okay.
that's
Okay.
You would know. I don't know.
Okay, like Kinsey actually wrote out why it was random, why it was independent, why it was normal. She just didn't do the actual math part, whereas Hunter has the actual math part. And then once you get done with the math, you still have to have a sentence like, this is the math I did, here's my answer. I'm 95% confident I'm between this and this. And most people, like, seriously, Luis just had math. He just straight up had math and the numbers and circled it because he thought this was calculus class, which sadly it's not, so I'm going to need some words.
I mean, we have a sentence, but like, so.
I didn't see a sentence on his.
You want us to check the conditions and write a sentence for each of the conditions.
No. So, if I had to make a list in my life, you do the conditions, you do the math,
So,
and then you have like a sentence explaining.
I got all of that. Like, I don't know what. Still don't know what it is.
Okay, well then maybe you didn't do anything wrong. Maybe I just handed everybody's back and didn't, once I read the first 4 papers wrong, I was like, and I will hand them all back, because that's what happened. Because for some reason his, and then his, and then hers were near the top, and after I read those 3, I was like, well, it's not looking good, I'm going to hand them all back.
Making assumptions to fit this class isn't generally a good thing to do.
That's true.
You look through your whole thing.
I was 90% confident, and clearly I did not hit the range on them.
So write a sentence for each of the conditions.
You do not have to write a sentence for each of the conditions.
Kinsey did, right?
No, she literally put random. And then she did have to write a sentence for that one. For independent, she did not write a sentence at all. She just showed the math.
Okay.
And then she showed the other bit of the math. And then for normal, she literally just showed the math. She did not write a sentence at all. The only one she technically wrote a sentence on was random. And that's only because in this problem they didn't tell you it was random, so you had to explain why it was random. But normally, thank Jesus, they tell you random. And you're just like, given. No, I do not like to write sentences. I only write them when necessary. Like at the end when I have to say I'm 95% confident I'm between this and this. I'm loving you over there. Keep asking me things. This is good. We're on the same level. He I don't know what level. I don't know where he is, but we are on the same plane. I did not realize how alike we were until right now.
Wow.
I know, right? Okay, I promise I'll stop saying words about math. In exchange for me to not say any words about math, will you have all this junk typed in L1 by tomorrow? That way we can just start off and do the math.
By tomorrow, they're done.
Yes, I'm telling you, I will stop saying words. If you'll just have that junk typed in L1 so we can just go straight to math tomorrow.